The world is full. In this presentation, you will see how overpopulation and the exploitation of our resources have affected our world. Fossil-based resources are being used exceedingly fast in today's economy. Many studies claim that the maximum point of extraction of crude oil, also called peak oil, has been surpassed. This is worrying as it means that we are seeing the loss or even the extinction of our natural resources. These resources are non-renewable, as it may take many lifetimes to replenish them, just as it took many years to create them. According to researchers at Stanford University, increasing population growth and energy consumption will result in life becoming progressively untenable. By the second half of the 21st century, the Earth's population is expected to grow to 9 billion people. More people means more consumption. The world will continue to see depletion of resources, especially non-renewable energy, so long as the population grows. Combined, the world has coal reserves of 892 billion tons. With today's rate of extraction, reserves will be exhausted in 113 years. Although renewable energy is highly talked about, these new technologies have limited impact on resource sustainability. Often we see that non-renewable resources are required to manufacture equipment for renewable energy, such as wind and solar power. Additionally, the production of ethanol and biodiesel from agricultural products like corn and soybeans has limited gains, as large-scale production of biofuels is unsustainable for the economy and the environment. Biomass cultivation for energy production requires the same resources as food production, like land and water. Thus, intensive agricultural procedures are needed to increase production, like fertilizers and pesticides. Consequences of these procedures are increased greenhouse gas emissions and shortage of food supply.
Globally, 1 in 9 people suffer from chronic malnutrition. If we consider only developing countries, that number increases to 1 in 8. Our food production industries are struggling to meet our current needs, and yet with a projected global population of over 9 billion people by 2050, we need an additional increase in food production of over 60% in as little as 35 years. But where can this expansion come from? Our agricultural resources are already overtaxed. Almost 70% of the world's agricultural soils are already slightly, moderately, or highly degraded due to erosion, salinization, compaction, and chemical pollution. Our growing needs are only going to exacerbate the challenges our environment already faces. A large part of the problem is that our agricultural processes are incredibly inefficient. An assessment commissioned by the United Nations Environment Program found agriculture as a whole is responsible for the consumption of 70% of the world's fresh water and nearly 21% of fossil fuels used. Over 50% of the world's crops are being used to feed livestock and not people. Livestock are responsible for producing an alarming amount of waste. According to the Environmental Protection Agency, livestock produce between 3 and 20 times more waste than people. That's between 1.2 and 1.3 billion tons of waste annually, contaminating rivers and groundwater. Cows alone contribute a significant amount of methane gas, adding to global greenhouse gases. There's a significant source of deforestation, as over 40% of all rainforests have been cleared for cattle pastures.
The amount of water on Earth is fixed. Less than 0.01% of the planet's 1.4 billion cubic kilometers is easily accessible freshwater in lakes and rivers. About a fifth of the water used worldwide comes from the 30% of the world's freshwater, which is stored in groundwater. In developed countries around the world, they alone have around 9 million people without access to safe drinking water. In Africa, for example, there is around 358 million people without safe drinking water. The dots are dots. Each dot would represent one person in this case. The small squares are 10 by 10, which are 100 dots. The big squares are a 10 by 10 grid of the small squares, so 10,000 dots. Now if you take the larger squares created, then make another 10 by 10 grid of them, that would be 1 million dots. 1 million people. Multiply that by 9, and that is the amount of people without safe drinking water in developed countries alone. This is a shocking amount if every single one of those dots is one person. In total, there are about 750 million people without clean, safe drinking water. which is almost 2.5 times the amount of people living in the United States. As climate changes warm the atmosphere and alters the cycle, we will continue to witness changes to the amount, timing, form, and intensity of precipitation, as well as the quality of environments. These changes are also likely to affect the programs designed to protect the quality of water resources and public health and safety. Water seems to be a growing concern, with the most recent effect being global warming. Whether you choose to believe in such a thing or not, climate change, however, is increasingly growing as a noticeable concern.
To summarize, we have argued that the Earth is full and that we are close to or have met the upper limits of what the Earth can support. The major issues we are facing are the following: limited and overexploited Earth resources, pollution, and an overgrown population. However, there is one possible solution that has become more of a reality in recent years. That is, space exploration. More specifically, interplanetary human settlements, space mining, water procural, and solar energy. This may seem unrealistic to some and straight out of science fiction, but many of our generation's greatest minds are in full support. Physicist Stephen Hawking is one of the major proponents for space exploration, stating, "Our population and our use of the finite resources of planet Earth are growing exponentially. Our only chance of long-term survival is not to remain inward looking to planet Earth, but to spread out into space." There are several ongoing projects and missions that are focused on the ways that space exploration can resolve these current and future issues that we're facing as a species. Solar energy is already being utilized in space, used to power rovers, satellites, and the International Space Station. Corporations such as the Space and Mining Resource Coalition and Deep Space Industries focus on research and development, aiming to mine asteroids and lunar surfaces for resources such as water, building materials, platinum, palladium, phosphorus, iron, nickel, and cobalt. On asteroids, these minerals are on the surface. A large asteroid, such as Eros, has an estimated $20,000 billion worth of precious metals, according to NASA in 1999. Similar asteroids have also deposited their minerals on the Moon's surface. Moon Express is just one of many private companies planning on moon missions, with the MX-1 blasting off this year on a reconnaissance mission for mining these minerals. NASA is also planning on mining water from the subsurface of the Moon. Also, it is the private corporation Mars One's goal to establish a human settlement on Mars. Mars One began crew selection processes in 2013. 200,000 people applied. Training will begin in 2015 and continue until the planned launch in 2024, with more crews to follow soon after. Additionally, the Mars Express mission, undertaken by NASA and the European Space Agency, was designed to study all aspects of the red planet, including its atmosphere and climate, and the mineralogy and geology of the surface and subsurface. This currently is focused primarily on initial research and testing, but with the rate of acceleration of technology, we may very well be establishing significant populations off-planet within the next several generations.